All right, let's do example 2. All right, example 2 says, in a tensile test, run, the yield load is 130 kilonewton, comma, the ultimate stress is 7,900 kilonewton per meter squared, and the rupture load is about 105 kilonewton. If the diameter of the circular bar is 40 millimeter and the neck diameter is 30 millimeter, estimate. Find number 1 there, maximum load. Number 2, tensile yield stress. Number 3, the rupture stress. Number 4, percentage reduction in area. Now, by the way, when it comes to strength of material can be categorized in 2 ways. We have the manual way and the how will I put it? We have the practical. Okay, we have the theoretical section and the practical section. The example we did earlier was a theoretical question. This becomes what? A practical question now. So let's solve this practical question and let's see what we get. So how do we solve this particular question? So the question says that after they have gone to lab and do some estimation, the information gathered was this. They said that in a tensile test run, the yield load is 130 newton. So givens, parameter per se, parameter there, I'm given that the yield load, there, I'm given yield load to be equal to 130 kilonewton. Next up, I'm given the ultimate stress. So I'm given the ultimate stress has been equal to 7 per se. Let me call ultimate stress. We know that stress is sigma. Let me call it ultimate stress to be equal to, we're given as 70,900 kilonewton as my ultimate stress value. Next up, rupture load. I'm given rupture load. Rupture load has been equal to 105 kilonewton. Diameter, I'm given, so listen up, I'm given to 2 diameter there. I'm given that if the diameter of the circular bar is 40 diameter, and I'm also given neck bar is 30 meter, which one is the real diameter? Is it diameter for circular bar or neck bar? The real diameter there is what? The circular bar. So diameter, which is D, go to what there? 40 millimeter as my real diameter. So I'm not given a neck diameter. Neck diameter, that's DN, equal to what there? Equal to 30 millimeter. So it becomes what we are actually given. So let's get this done, please. How do we solve this particular problem? All right, let's get this done, please. First, I'm told to calculate what? Number 1 there, the maximum load, right? So maximum load there. So my first, I'm given diameter. We said I can actually get area using what? Diameter. So mind you, I'm also given neck diameter, right? So I can look for 2 areas now. I can even look for what? My area neck and normal area, right? Because diameter neck, so I should have area neck. So this one's my diameter, I'll have normal area. So let's look for area first. I need the area. I'll show you why I did area first. So my area is equal to what? Pi d squared over 4. What's pi? 3.142 times what's this squared? What's the 40? Please, are we converting? No conversion. millimeter, millimeter, kilonewton, kilonewton, kilonewton. No conversion, please. No conversion, please. Hang on. Sorry, this man was slash meter squared, please. Oh, please. The ultimate stress is given in terms of kilonewton per meter squared, please. So I'll convert. This is meter squared. I'll convert this to meter. So convert it to meter. What do I get? Convert it to meter. 0.04 meters. This will become 0.03 meters, please. So I have this, right? I have this. All right. So times diameter now becomes my d squared. That's 0.04. 0.04 all squared all over 4. So this gives area now is equal to, if I multiply these two together, how about my area there becomes 1.26 times 10 to the power minus 3 meter squared. This is my normal area. Let's now look for the neck area. So AN, let me call it neck area, is equal to what? By d neck squared all over 4. 3.142 times what's my neck diameter? That's dn is what? 0.03. 0.03 all squared all over what there? All over 4. At this point now, if I multiply these two together, what will be my area for neck diameter? So of course, the area for my neck diameter becomes AN is equal to, multiply this and divide by 4. I'll have about 707 times 10 to the power minus 4 meter squared. So I have known my area now for each. This is my normal area and neck area is given now. I know them. So let's now get this done, please. So question says now, what question number 1 says? I says that calculate what? The maximum load. So I'm looking for maximum load. Maximum load. So how do you get my maximum load? Recall that ultimate stress is equal to maximum load all over area, please. This becomes your formula. Are we given ultimate stress? Of course, yes. Ultimate stress is what? Is this man here. So I'm looking for maximum load, Abi. Let's make maximum load subject. From here, maximum load is equal to what? Ultimate stress times area. Let me put area. So maximum load now, maximum load is equal to what's ultimate stress? That's what? 70,900 times what's value for area there? Normal area is what? 1.26. 1.26 times 10 to the power minus 3. Multiply these two. My maximum load is equal to, multiply these two, what do I get there? I'll have my answer to be equal to 8.9.334 kilonewton. We know that load, irrespective, since it's a load, and load is measured in what? In kilonewton. It becomes my answer for the first question there. Because the second question says find tensile yield stress. So II tensile yield stress. Let me call it stress Abi, but tensile T. Let me call it T sigma. That's tensile yield stress, right? So I'm saying that tensile yield stress is equal to um yield load all over area. Please master this formula, please. So tensile yield stress is equal to what? Yield load all over area. What's my yield load? Yield load is of course given. That's 130. So I have 130 over what's area? Normal area, please. That's 1.26. 1.26 times 10 to the power minus 3. From here, I will have that my tensile yield stress will be equal in value to 103.17 kilonewton per meter squared. Observe, this is stress, and stress is measured in what? Kilonewton per meter squared. So this becomes my SI unit. This becomes the second answer to the second question there. The third question says the rupture stress. So I the rupture stress. We know that stress is what? Force over area, right? So hence, let me call it rupture stress sigma R equal to that becomes rupture load all over area. So what I get there? Rupture stress equal to what? Rupture load. Rupture load is what? 105. So I'm given 105 all over normal area is what? 1.26 times 10 to the power minus 3. This will give about 833.3 stress kilonewton per meter squared. So I have that as my answer. All right, let's get the last one part done. The last part says that percentage reduction in area. So let's do that part. Let's do that part. Get the percentage reduction in area. That becomes your neck area minus original area all over original area times 100%. So what's my neck area? Check your book. I have about 7.07 times 10 to the power minus 4 times what's our normal area? That's 1.26 minus 3 all over 1.26 times 10 to the power minus 3. From here, what do we get? It becomes multiply these two numerator and divide by denominator. I have about minus 43.88. So my reduction there becomes a negative 43.88. But in terms of percentage, I should not be times 100, please. At this point, I should not be having a negative sign, right? So my normal, so I'll ignore the negative sign. That becomes 43.88% becomes my answer to that question, please. So let's have to solve this particular problem using the idea of the basic concept we have learned so far. So at this point now, we'll look at next class. Look at the concept of thermal stress and strain, right? Thermal stress and strain.